Hello everyone, my name is Qcode and welcome back to our Löve Tutorialy series thingy episode 11. We already have a collision check set up, so when you collide with a point it will print true, but currently it doesn't do anything, so we're going to change that by adding a points counter. So I'm going to make a variable in love.load called points counter and say points counter equals 0. Very simple, this will be counting how many points we collect. Then every time we collect a point, we will say points counter equals points counter plus 1. That should be simple enough. Check collision. It says if these two squares are touching, then the points counter should increase. Otherwise, don't do anything. So, the points counter works. As of right now, you can't see how many points you've got, so the points counter is absolutely useless. So we're going to change that by using love.graphics.print. We haven't used this in quite a while. Alright, love.graphics.print. We're going to be printing the points counter, just so we can see how many we have. And we'll put it at 500, so it'll be at the top of the screen, a fair bit over. There you go, up in the top, up there you've got your points, 0. However, as you can see, the points just increase. I stopped at around 200. Points just increase when your square is colliding. We don't want it to do that, we just want it to have 1 point pickup each time we touch the point, and then have the point disappear instead of just having it incrementally count up. So how are we going to do that? Well, we're going to need to figure out how to remove the point from the points table. There's actually a handy function for doing this called a table.remove. So now, when we check for the collision, we're going to still make the points counter go up, but we're also going to add another value to the point we're currently checking, and that is v.delete. I'm just making this up on the spot. We'll say v.delete equals true. That'll be marked, so okay, we've collided with this, now we have to delete it. Now what we're going to do is we're going to loop through all of the points, check if any of them need to be deleted, and then if so, delete them. The only problem is that we can't loop through the points in the usual way we do with I, V in pairs. The reason why for this, I've drawn a handy little diagram here. Let's say we have 5 points currently on the screen, and 2 of them need to be deleted. You can see there Y and Y, those both need to be deleted. If we were to loop through all of them numerically, say 1, 2, 3, 4, 5, then try to delete the first one, all the other ones would get shifted down. So now it would be 1, yes, 2, no, 3, no, 4, no, and 5. No, sorry, no 5 because one of them's gotten deleted. 2 now becomes 1, 3 becomes 2, 4 becomes 3, 5 becomes 4. Because this one's been removed, all of these entries are shifted down. That is how the table.remove function works. Hopefully that makes sense. The thing is, the counter is still going. So when we're using our counter, it starts on 1, goes all the way to 5. There are 2 problems with this. 1. When the counter gets to 5, there's not going to be a point to check whether it's deleted or not. That's going to throw an error because the program is looking for a point that does not exist. Problem 2 is that some points can be missed during deletion. For example, we start the counter, it goes to 1, gets deleted, all of them shift down. Now the counter goes to 2 in this refined list, which is actually 3 in the original list. As you can see, the counter has skipped over 2 in the original list, or 1 in the new list, because of the entries being moved over. The way that we fix this is we go through the entries backwards instead of forwards. So we start on 5 and go to 1. So counter checks 5, no, nothing happens. 4, nothing happens. 3, nothing happens. 2, something happens. The entry 2 is deleted. The rest of these, 3, 4 and 5, are shifted down, and the counter goes to 1, which is the same in both lists, because it's been unaffected by the entries on top of it shifting down or being deleted. It may be slightly confusing, but that's the best explanation I can offer. Now how we actually get into programming a reverse loop. Instead of using the generic for, we use the numeric for with a couple of different circumstances. So we write for. If you remember this from the loops episode, the numeric for starts with a value, so for x equals, you put the number that you want to start at, so that will be the number of points, you put the number you want to end at, 1, and you put the number you want to modify by, which will be -1. So it starts at points, goes -1, -1, -1, -1, until it reaches the beginning of the index, and then the loop will close. Now all we need to do is simply check if the point needs to be deleted. So we write if points x dot delete, then now we get to use the function table.remove. I've linked this in the wiki, it's got a page here. All we're really going to be using it for is with 2 arguments, table.remove. First you want to put the table that you want to remove from, which is the whole points thing, and then you want to put the index that you want to remove, which is simply x, because x correlates with the one that needs to be deleted on this current check. It is removed, we are good, and then eventually the loop will finish. If we build this, you see, we can pick up the point, and now we have one whole point. This episode is already starting to get a little longer than I usually do, so I'm just going to end it off here. Next episode we're going to be going over how to randomly spawn a point whenever one is collected. Thank you everyone for watching, and I hope to see you all next time. Goodbye!